Hello, you're with Bahati Abdul Karim, and I'm taking you through A-Level Applied Mathematics. In this video, we're going to look at the last part of projectiles. Let's look at what we're going to cover today. We're going to look at release at an angle from a given height, and this is the last part of projectiles. Our first question says, a particle is projected from a height of 12 meters with a velocity of 19.6 meters per second at an angle of 30 degrees to the horizontal. Find the time taken for the particle to reach the ground, and then part B, the maximum height above the ground reached by the particle. So when you look at our particle here, it was released at a distance of 12 meters above the level ground and given an initial velocity of 19.6 meters per second at an angle of 30 degrees. They want us to find the time it takes to fly from here up to this point and also the maximum height above the ground, which is this distance here. So let's see how we're going to calculate those two. To calculate the time taken, I'm going to consider a vertical motion, and I'm going to use one of the three equations of motion. The suitable equation is the second equation of motion. So I will say using S is equaling to ut plus a half at squared, and considering the vertical motion, we have our S equaling to negative 12 meters. It's a negative because it is below the point of projection. The object was projected from this point, and this 12 is below the point of projection, so it becomes a negative. And then our U is going to be 19.6, but to the vertical it becomes 19.6 sine of 30 degrees. 19.6 sine of 30 degrees. And then our T, it is what we are looking for, so we can say T is equal to a question mark. Then our acceleration P will always equal to negative G, and will always equal to 9.8 meters per second squared. It is a negative because we are opposing gravity. So this T can be the same as that one. So if we substitute this information in our equation, we are going to have negative 12 equaling to our U is 19.6 sine of 30 degrees, then times the time T minus a half times 9.8 times T squared. So you realize that here, if we try to simplify this, we will have negative 12 equaling to sine of 30 is 0.5, and 19.6 times 0.5, we're going to have 9.8. Then T minus 9.8 divided by 2, we're going to have 4.9 T squared. So when you reach at this point, you realize that you have a quadratic equation. And in mathematics, we embrace technology. You're allowed to put this on the calculator and get the two T's. So if you want, you can bring 12 this side and you will have negative 4.9 T squared plus 9.8 T, then plus 12, which will equal to 0. This is a quadratic equation that you can solve using any of the methods. But if you put this on the calculator, you will get your time as the first time T1 will be 2.8 0.86 seconds, and T2 will be as 0.857, and this is a negative. So with these two times, we're going to ignore the negative, and we can conclude that therefore the time taken T will be 2.86 seconds. And this is part A of the question. So in this part, we have calculated the time taken by the particle to move from the point where it was projected to the point where it landed. So the second part says that we calculate the maximum height above the ground reached by the particle. And in this case, we need the distance from here up to here. This is the maximum height above the ground. But you realize that we have some distance which is 12. So this distance here is 12 meters. So we don't need to calculate it. So what is missing is this, and we can call it h. That means we have to calculate this h and we add there 12 because we already have our 12. So how can we calculate this? From the previous videos, we looked at how we can calculate maximum height for projection at an angle. Let's see how we can get this h and then add there 12 to get the total height above the ground. So here we are going to use the third equation of motion, which is using v squared is equaling to u squared plus 2as, and we're going to consider vertical motion. We know that our v at maximum height will always be 0, and u for vertical motion will be 19.6 sine of 30 degrees. And then our acceleration will always be a negative 9.8 meters per second squared. Our s is equaling to capital H, which we are looking for. So when we substitute this information in here, we're going to have a 0 squared equaling to a u squared, which is 19.6 sine of 30 degrees squared, then minus 2 times 9.8, which is the acceleration, times the h, which is the height we are looking for. So from here, we'll have 0 equaling to 19.6 sine of 30 divided by 2. We're going to have 9.8 squared. Then minus 19.6 h. And when we bring 19.6 h this side, we'll have it equal to 9.8 squared. And if you divide by 19.6 by 19.6, if you want, you can square 9.8 and get the result. Here we shall get 4.9 meters. So after getting that h, we can say that for the maximum height above the ground is 4.9 plus 12. And here we're going to get it as 16.9 meters. So this is the maximum height reached by the particle. We can now look at our next question. The next question says, a particle is projected at a velocity of 15 meters per second at an angle of 25 degrees to the horizontal. The particle is projected from the back of a raised platform that is 1 meter high and extends for 5 meters. Find the time taken for the particle to reach the ground. And then part B, the velocity with which the particle hits the ground and the angle it makes with the horizontal at this time. So let's look at the particle motion. You see the particle is projected from this point, which is 5 meters. That point is 5 meters behind this point here. As they say, it is projected from the back of a raised platform. This is the back of a raised platform, and the platform is 1 meter high and it extends 5 meters, as you can see. And we want the time taken for the particle to reach the ground from here up to here, and then the velocity with which the particle hits the ground and the angle it makes with the horizontal. So I told you that if you want the velocity here, you need v. This velocity will be the square root of the velocity in the x squared plus the velocity in the y squared. So if you want the angle will be, remember, the velocity in the y goes like this and the velocity in the x goes like that. So the angle will be this angle here, theta. So the angle will be this to the horizontal, as this will be the resultant velocity. So we need this angle and we need this velocity. That is for part B. And then for part A, the time taken, that one we have already seen how we can calculate it. Let's start with part A and see how we can calculate the time taken. So for part A, we're going to use the second equation of motion, which is S is equal to ut plus a half at squared, and we're going to consider vertical motion. Our S is going to be a -1. As I told you, this is a negative because it is below the point of projection. Our U is going to be 15 meters per second sine of 25 degrees. 15 sine of 25 degrees. And then our time, we can call it t. We can call our acceleration a -9.8 meters per second squared. So with this information, we can substitute here and we can calculate the time taken by the particle to reach the ground. So our S is -1, which will equal to our U, which is 15 sine of 25 degrees, and then times t minus a half times 9.8, and then times t squared. You realize that this is also a quadratic equation. So if we try to simplify this one, we can bring this side and we'll have 4.9 t squared, whereby I divided 9.8 by 2 to get 4.9 t squared, and it is a positive because it went this side, and this will be a -15 sine of 25, and then the whole of this is multiplied by t, then this is a -1, and we can equate this to 0. So this is a quadratic equation, and when you solve it, you will get your T1 equaling to 1.44 and seconds, and your T2 will be equaling to -0.142 seconds. So we discard the negative and take the positive, and we can conclude and say, therefore, the time taken by the particle to reach the ground is t equaling to 1.44 seconds. Let me hope this is clear to everyone, and that is how we calculate time taken. For part B, we need to calculate the velocity with which the particle hits the ground and the angle it makes with the horizontal at this time. here we are answering part B, and we are going to use the third equation of motion, which is v squared is equal to u squared plus 2as. And we are considering vertical motion, and let's say our velocity will be v in the y, our u will be 15 sine of 25 degrees, and our acceleration will always be negative 9.8 meters per second squared. Our s will equal to negative 1 meters. So substituting this information into this equation, we're going to have our velocity in the y squared equaling to u squared, which is 15 sine of 25 degrees squared, then plus 2 times 9.8, then this is a negative times our negative 1. So finally, you will have your v squared in the y equaling to 59.786, and if you take the root both sides, you're going to have your v in the y equaling to 7.73 meters per second. That's how we can get the velocity in the y. Remember to have the resultant velocity, or velocity with which the particle hits the ground. You need the vertical component of velocity, which is vy, and also v in the x. So we said v in the x is always equal to u in the x because there is no acceleration, and we know that u in the x is 15 cos of 25 degrees, and this will give us 13.6 meters per second. So with these two components of velocity, we can now calculate the resultant velocity. So we know that if we have the horizontal component of velocity, it will be like that, and the vertical will be like this. So the vertical is 7.73, and the horizontal is 13.6. So here we need the resultant velocity, which we can call v, and then the angle it makes with the horizontal ground. So before we use this v, we need to first let it. Maybe we can say let the resultant velocity with which the particle hits the ground be v. I'm going to write velocity be v because I don't have space. So after getting this, after letting it to be v, you can now say your v is equal to the root of 13.6 squared plus 7.73 squared. And finally, you will have your v equaling to 15.6 meters per second. So that's how you can get your velocity. Then after the velocity, we need to get this angle. To get this angle, we will use tan of theta is equal to opposite over the adjacent. This is the same as 13.6. So let me erase this part so that we can calculate that theta. We are still on part B, and we said our horizontal was 13.6, our vertical was 7.73. We are interested in this angle theta. We have got this V as 15.6 meters per second. So you can use any. If you want to use cos, you can use it. If you want to use cos, you have the hypotenuse already. If you want to use tan, you can use it. If you want to use sine, you can still use it. This will also be 13.6. So if I use tan of theta, it will be opposite, which is 7.73 out of 13.6. And my theta will be tan inverse of 7.73 out of 13.6. 29.6. Finally, my angle will be 29.6 degrees. And that's all. You can see the thing is very simple. So, since we have already calculated our velocity which they wanted and the theta, we can now go to the next question. So the next part is looking at clearing an obstacle. So we have a particle which is projected with a velocity of 10 meters per second at an angle of 35 to the horizontal. A wall of height 1.5 meters lies 5 meters horizontally from the point of projection. They want us to find out if this particle will clear this wall of 1.5 meters. To find this, we need to find the distance in the y at which the particle will be when its distance in the x will be 5 meters. After finding out that distance, we compare it with 1.5 and see. If it is greater than 1.5, then we say yes, it will clear the wall. If it is less than 1.5, we say no, it will not clear the wall. So this is our particle which moved from this point, and it may have cleared the wall or it may have not cleared the wall. So to find out, we just need to find the height at which this particle will be when its horizontal distance will be 5 meters. If this height is greater than 1.5, then the particle will clear the wall. If it is less than 1.5, then the answer will be no, it doesn't, it will not clear the wall. So let's see how we calculate this height at which the particle will be when its x or its horizontal displacement will be 5 meters. So to do that, we are going to use the second equation of motion, and we're going to consider horizontal motion because we want to find the time taken by the particle to reach 5 meters horizontally. After getting that time, we can use that time and calculate the height or the vertical displacement for the particle at that time. So the first thing to do is find the time when the particle will be 5 meters from the point of projection. So let's go and calculate that time. Actually, we can even calculate it from here using the second equation of motion, which is using S is equal to ut plus a half at squared, and we are considering horizontal motion. We know that S is equal to 5 meters. Then we know that U is equal to 10 cos of 35 degrees. We know that the time is what we are looking for, and acceleration is equal to 0. So using this information, we can get time. Let's go to the next slide. So here, our S is equal to ut plus a half at squared, and we are considering horizontal motion. So our S is 5 meters in the x, and our U is 10 cos of 35 degrees, then times t, then plus a half times 0 times t squared. So here we're going to have 5 equaling to 10 cos of 35t. We can divide by 10 cos of 35, 10 cos of 35, and this will go with that, and will remain with our time equaling to 0.610 seconds. So this is the time taken by the particle to cover a distance of 5 meters horizontally. So with this, we can still use the same equation, but now considering vertical motion. So let me erase this one so that we can get space, or I can calculate from here. So I will say using S is equal to UT plus a half AT squared. Our S, we are considering vertical motion. I can say that our S can be S in the Y. Since we don't know it, we know that U in the Y will be 10 sine of 35 degrees. Our time is equal to 0.610. Our acceleration is negative 9.8. Substituting this information in this equation, we are going to have our S in the Y equal to 10 sine of 35 times 0.610, which is our time, minus a half times negative 9.8 times 0.610, and this one is squared. So when you simplify that, you will have your S in the Y equal to 1.68 meters. So at time equaling to 0.610, the particle will have covered, or will be at a vertical displacement of 1.68, and it will have covered 5 meters in the horizontal. So since the wall is 1.5, that means that yes, the ball will clear the wall of 1.5 meters. Since the particle will be at 1.68 and the wall is 1.5, then it is a yes. If this distance was below or was less than 1.5, then it would be a no. The particle or the ball will not clear the wall. So that is how we can answer that question of clearing the obstacle. So our last part, we're going to look at examination style questions. Let's see how these questions may look like. Our first question says a ball is thrown from a point O with a velocity of 10 meters per second at an angle of 0 degrees to the horizontal. At time t seconds after projection, the ball is at the point xy. Part A, Roman 1. Find the expression in terms of theta and t for x and y. Roman 2. By eliminating t, find the equation of the trajectory of the ball. And then here they are saying, in the case where theta is equal to 45 degrees, find part B, Roman 1, the maximum height of the ball above the level of projection, and Roman 2, the time of the flight. So in here, we're going to find the expressions in terms of theta and t for x and y. So let's start with the expression for x. That is like the horizontal displacement. So for this horizontal displacement, that means we are going to consider motion in the x, and I'm going to use the second equation of motion. So using S is equal to UT plus a half AT squared, and considering horizontal motion with S equal to x, we know that U in the x, remember they gave us U as 10 and the angle as theta. So we're going to say U is equal to 10 cos of theta. And then time can remain as time t. We know that our acceleration will always equal to 0 in the x. So using this information, I will say x is equal to 10 cos of theta, then times our time t plus a half times 0 times t squared. And finally, our x will equal to 10 cos of theta times t. I think we can put t outside here. So this is the expression of x in terms of theta and t. We can now look for the one of y. And we are answering part A, Roman 1 of the question. This is part A, and it is Roman 1. So let us also look for the expression for y. We are still going to use the second equation of motion, s is equal to ut plus a half at squared. And in this case, we are considering vertical motion with our s equaling to y, our u equaling to 10 sine of theta, our t can equal to t, our acceleration will be negative 9.8 meters per second squared. If we put this information in this second equation of motion, we're going to have s, which is y, equaling to u. Our u is 10 sine of theta times t minus a half times 9.8. The negative is for 9.8 times t squared. And finally, if we simplify this, we're going to have y equaling to 10t sine of theta minus 4.9 t squared. So this will become our equation 2, and this was our equation 1. So in this case, we have finished expressing in terms of theta and t, x and y. So we have expressed x and y in terms of theta and t. Now they want us to eliminate t to find the equation of trajectory of the ball. So let us eliminate t from both equations. These are our two equations, we just need to eliminate t. That means we make t the subject in this equation and we substitute it in this equation. So we can do that. Let me erase this information. So we know that, let me first rewrite our equations. Our equation 1 was x equaling to 10t cos of theta. That was our equation 1. And our equation 2 was y equaling to 10t sine of theta minus 4.9 t squared. This was our equation 2. So we can make t the subject here and substitute it here. So we can say making t the subject in equation 1, we're going to have t equaling to x out of 10 cos of theta. And then we bring it and we substitute it in here. So we are going to have y equaling to 10 times x out of 10 cos of theta, then t is x out of 10 cos of theta, then times sine of theta, then minus 4.9 times x out of 10 cos of theta, and this part is squared. So when we do that, we end up getting this 10 will go with this 10, and this x will remain. So we'll have a y equaling to x. We know that sine of theta out of cos of theta is tan theta. Then minus 4.9 into x squared out of 100 cos squared theta. So this becomes the equation they wanted us to look for. By eliminating t, find the equation of the trajectory of the ball. So this is the equation of the trajectory. And then part C, they want us to substitute theta equaling to 45, and we find the maximum height of the ball above the level of projection. And then Roman 2, they want us to calculate the time of flight. So this here was Roman 2 of part A. So this is what we have been answering. So for part B, Roman 1, we are going to use v squared is equal to u squared plus 2as. Considering vertical motion, we know v at maximum height is 0 because they want us to find the maximum height of the ball above the level of projection. So for maximum height, we know that this is 0, and our u in the y will be, we have our initial velocity as 10, it will be 10 now sine of 45 because they have given us the theta. And then our acceleration will be negative 9.8 meters per second squared. Our s is what we are looking for. We can call it h. So substituting this information here, we have 0 squared equaling to 10 sine of 45 degrees, then minus 2 times 9.8 h. And we shall have 0 equaling to 10 sine of 45 degrees minus 19.6 h. If we bring 19.6 this side, we shall have 19.6 h equaling to 10 sine of 45 degrees divided by 19.6 by 19.6. We shall have our h equaling to 2.55 meters. So that is the maximum height. Then the last part wants us to calculate the time of the flight. So for the time of flight, we are going to use the second equation of motion. So let me remove this information here. We are now on part B, Roman 2, and we are going to use S is equal to ut plus a half at squared. We are considering vertical motion, and we have with S equaling to 0. For time of flight, when a particle moves from this point up to this point, its displacement in y is 0 at both points. So at this point here, y is equaling to 0. That means S in the y is 0. That's why I'm making that S a 0. And then our u is equaling to 10 sine of 45 degrees. So our t can be taken as t, and acceleration will be negative 9.8. So if we substitute this information here, we're going to have 0 equaling to u, which is 10 sine of 45 degrees times t minus a half times 9.8 t squared. So when we factorize t outside, we're going to have 10 sine of 45 degrees minus 9.8 divided by 2 is 4.9 t into t. So if you have a product equaling to 0, that means one of them is 0. So we shall have either t equaling to 0 or 10 sine of 45 degrees minus 4.9 t equaling to 0. And here when we simplify, we'll get 10 sine of 45 degrees out of 4.9. And finally, our t will be 1.44 seconds. So this is how we can calculate the time of flight. So that is our time of flight. So at this moment, allow me to wish you all the best. Let's meet in the next video, which will be about flowcharts. Thank you for watching. May God bless you.